Alright, so picking up where we left off with 9.4, I didn't quite get finished. I wanted to do a couple more examples, and there is one more thing I want to talk about on top of that. But we're talking about the ratio test here, and what we're going to do if we want to verify that this converges and find the interval of convergence for it, then we need to use a test to do this, and we're going to use the ratio test. Now remember, the ratio test, you're going to take the limit as n approaches infinity, and what you're going to do is you're going to do a sub n plus 1 divided by a sub n. Now in this case, what that's going to give us is this, the limit as n approaches infinity. For n plus 1, we're just going to take everywhere we've got an n here, and we're going to put an n plus 1. So we end up with n plus 1 over 3 to the n plus 1. And on top, I've got x minus 5 to the n. So that's going to give x plus 5 to the n plus 1. Oh, and by the way, this is absolute value here. All right. And then instead of doing the division, we're going to go ahead and do the keep, change, flip. So I'm going to multiply by the reciprocal of this with only n's where everything is an n. So that would give me 3 to the n on top. It's going to give me n from this one right here, and x plus 5 to the n power right there. All right, and once again, that is absolute value. So what that gets us when we reorganize just a little bit here, keep all the stuff that's on top, and all the stuff that's on bottom, but you can rearrange it in any order you want to so that they kind of correspond. So I'm going to have the limit as n approaches infinity. Now I'm going to do my n plus 1 and my n together. And you can write this as one big fraction, or you can break it up in either way. And then I'm going to do my 3 to the n over 3 to the n plus 1. And then x plus 5 to the n plus 1 on top over x plus 5 to the n power on bottom. And like I said, you can do this as one big part, still absolute value, and you can think about it in pieces. Or what I usually do is I'll usually just go ahead and split this thing up into fractions, different fractions. This fraction times this fraction times this fraction gives me the same thing I've got right here. I've just got everything organized where it's a little more easy to deal with. So I can simplify things. Can't simplify this. So I've got the limit as n approaches infinity of the absolute value of n plus 1 over n. Now here I can simplify this. I've got 3 to the n power, and I've got 3 to the n plus 1 power. That means I multiply by 3 one more time down here. So it's 1/3. Now you can also think of this as 3 to the n times 3 to the 1, and the 3 to the n's would cancel out. Either way you think about it, that middle fraction there simplifies to 1/3. All right, and then this last one here, I have the same similar situation that I've got right here. I've got one more x plus 5 on top than I do on bottom. So I know I'm going to have x plus 5, and you can put that over 1, or you can just write it there. Now when we take our limit here, what's going to happen with the n plus 1 over n? Well, remember, as n goes to infinity, this 1's going to become negligible, so it's going to become like an n over n, which is going to mean that that's going to go to 1. So you have 1 from the first part. What's the limit as n goes to infinity of 1/3? Well, there's no n involved there, so it's just 1/3. And then the x plus 5, once again, we've dealt with the n, so we don't have an n there, so it's just going to be x plus 5. Now, what do we know? Well, we know that this limit has to be, the absolute value of this limit has to be less than 1 for this thing to converge. Now, it is possible because we can put values in here that's going to make this overall thing less than 1. We can ignore the 1 here, but the absolute value of 1/3 times x to the 5th, there are x values that we can plug in there that are going to keep this less than 1. We need to find out what those are, though. So we've got 1/3 times x plus 5. Now remember, with the absolute value inequality, you're going to have it less than +1, but you're going to have it greater than -1. All right, so then we can just go through our algebra, multiply all the parts by 3. That'll get rid of my 1/3. So you end up with -3 is less than x plus 5 is less than 3. All right, and then we're going to subtract, that's a minus. All the way back to the beginning, that should have been a minus. And minus, minus. So go back and fix all those if you wrote them down the same way I did and didn't catch my mistake at the beginning. I knew that wasn't, something was wrong. So minus. All right, so I'm going to add 5 to all the parts, and that means I'm going to have x. -3 plus 5 is going to be +2, and +3 plus 5 is going to be 8. So my interval of convergence is from 2 to 8. Now, that's my interval of convergence. That's the x values for which this function right here, or this series, will converge. So what is your radius? Well, remember, all you're doing to find the radius is you're finding the width or the length of your interval and dividing it by 2. So 8 minus 2 gives you 6, and half of 6 gives you 3. So it has a radius of convergence of 3. All right, let's look at one more. All right, same thing. We're going to do the ratio test again. And to do the ratio test, we're going to take the limit as n goes to infinity of the absolute value of this term, the n plus 1th term. So n plus 1 factorial over n plus 1 to the 4th power times x minus 3 to the n plus 1 power. All right, and I'm going to multiply that by the nth term, and that means I'm just going to write this thing down, but I'm going to flip everything over. So I'm going to have n to the 4th power over n factorial times x minus 3 to the n power, an absolute value there. All right, so when I write everything, I'm going to have, when I start putting it together, I'm going to have the absolute value of n plus 1 factorial over n factorial, and I'm going to have x minus 3 to the n plus 1 over x minus 3 to the n, and then I've got n to the 4th over n plus 1 to the 4th. All right, and once again, absolute value there. So we've got the limit as n approaches infinity. Now, what's going to happen here, we go ahead and simplify. We know that if we have n plus 1 factorial, we have 1 times 2 times 3 times 4 times dot 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 n times n plus 1. And then if we have n factorial on the bottom, that means we have 1 times 2 times 3 times 4 times dot 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 all the way up to n. So that means that this cancels with that cancels with that cancels with that cancels with that, etc. Another way you can think about it is that n plus 1 factorial is n factorial times one more term of n plus 1. And that over n factorial, that means these cancel out, so you're only left with an n plus 1 on top. All right, when we deal with our x minus 3 to the n plus 1 over x minus 3 to the n, that means we're going to have one more term of x minus 3 on top. And then the n to the fourth over n plus 1 to the fourth. Little trick here is we can actually pull, since they're both the same power, we can write this as n over n plus 1 all raised to the fourth power. It's kind of the reverse of the a over b all raised to the fourth power is a to the fourth over b to the fourth. How we distribute that power, this is kind of the backwards version of it. We just use the same relationship, the same property in reverse, and then when we have that, we've got n over n plus 1, and this is all to the fourth power. But what happens when we take the limit as n goes to infinity? So then you just go in, and when you take the limit, taking the limit of this part's easy because we just took it in the last example. N over n plus 1, the 1 becomes negligible, so this is going to go to 1. So this part goes to 1 to the fourth power, which is still 1. And then what happens to this n right here? Well, this n plus 1, that means that this thing is going to actually go to infinity. Now what that means is that since this isn't approaching some simplified value that we can actually find and set the x plus 3 equal to or less than or equal to 1 or less than 1, then this thing is not going to have a interval of convergence. It's going to have a single value because n, this part right here, this part's going off to infinity all the time. When n goes to infinity, n plus 1 is going to infinity. What's the only case where we're not going to continue to add term after term after term of bigger and bigger values? Well, the only case where that's not going to be true is if this thing right here equals 0. So that means that if x equals 3, that means we're adding 0 over and over and over again regardless of what n is going to be. So x equals 3 is the only value that the series does not diverge. And it actually converges to 0, a sum of 0, because that's all we're adding is 0, 0, 0, 0, 0. But that's the only case where the thing is not going to diverge. Every other value of x, the thing is going to diverge. All right, and one other thing here. Let me make a note here. If your radius of convergence is infinite, that just simply means that no matter what value of x you have, that series is going to converge. And that is a possibility. So don't think that you can get an r that's so large that, well, there's no way that radius can work. No, if all values of x make the series converge, then your radius is infinite. All right, now another series for which it's easy to find the sum is called a telescoping series. It's called telescoping because, well, they kind of run into each other. The second term or the second part of the first term will knock out the first part of the second term. it's kind of weird until you actually see it. It's hard to see. So if we use partial fractions on this, we're going to end up getting A is 1 and B is negative 1. So that means that this thing right here becomes this thing right here. So if we do the term when n is 1, we get 1 over 1 minus 1 over 1 plus 1. So we get 1 minus 1 half. There's the first term. So that's a sub n, or sorry, a sub 1. This is a sub 2. This is a sub 3. And you're going to notice that minus 1 half here and the positive 1 half here would cancel each other out. We're adding them, so those just cancel each other out. And what about the negative 1/3 and the positive 1/3? They're going to cancel each other out. So what's the only thing that's left and it's not canceling out for each next consecutive term? Well, the 1 here is stuck there. It doesn't have anything to cancel out with. And as we keep looking, what are we going to end up with? How much away from, is it going to converge to 1? Well, if this part right here goes to 0 as n gets larger and larger and larger, then what does that mean? We're going to have 1 plus some really, really tiny number later on, so the limit would go to 1. So this series would actually approach 1. The sum would be approaching 1. So your nth term turns out to be 1 minus 1 over n plus 1. So then if you take the limit of this part right here and find out what it's going to do, as long as this term goes to 0, then that's what your sum is that first term. So if you take the limit of this s of n, in other words, this half over here, where n goes to infinity, this is going to go to 0, so you end up with 1 minus 0, which ended up being 1. Now, on the problems where you're trying to find these solutions, the sums, you're going to have to use partial fractions because you need that second part right there. The first part for n equals 1 or n equals 0, whatever the first term is going to give you the first value. Remember, that's the value here, like with this one, that did not cancel out. But you need this to be able to tell and determine whether or not this second term is going to go to 0. If it doesn't, then this thing's going to diverge. But if that second term that you're adding to it, in this case subtracting from it every time, does not go to 0, then that's what we end up having there. We end up having a situation, if this doesn't go to 0, we end up with a divergent series. If it does, then we end up with a convergent series. And if it's a minus right here, then we can figure out what it is. If it's a plus, you can't do that. Yeah, you can. Never mind. Sorry, that's right. Because it's still going to cancel out.